Okay, Assalamualaikum and good day. So we continue with the lecture topic 7. So we have 3 lectures for this topic, which is 7.0 probability, and the first subtopic will be the events and probability. So subtopic yang kedua, the second subtopic 7.2 is the probability of mutually exclusive event. Okay, so for this lecture, we are going to focus on why? Sorry. Uh, see or start where they go to. Okay. Okay, so the learning outcome of this lesson or this lecture, at the end of the lesson, students should be able to, the first one is to define the concept of experiments, outcomes, events, sample space, and random selection. And then for 7.1b, to find the probability of an event and apply the basic laws of probability. Okay, that's for 7.1. And then for 7.2, we are going to use the formula of probability of A union with B equal to probability of A plus with probability of B, and then subtract with the probability of A intersect with B. And then for B, identify the concept of mutually exclusive event and apply probability of A union with B is equal to probability of A plus probability of B. Okay, this is when we have a mutually exclusive event only. Okay. And lastly, C, use the complement formula for probability. So probability of A prime minus probability of is equal to 1 minus probability of A. So another method to write down this one is equal to probability of A bar. Okay, so this is the same as probability of A prime. Okay, so the content, so experiment, outcome, sample spaces, event, and random selection. So these are the terms that you have to know and understand what it means. Okay, for this one, what is experiment? So a random experiment is an action or process that leads to one of several possible outcomes. So usually you do experiment in labs, right? But now we can do experiment anywhere in your house or your own room, and everywhere in the field or in the cafeteria, you can do any experiment. So this experiment is an action that will lead you into several possible outcomes. So there may be no outcome at all. Okay, so you can see the experiment is just some random works you do to have some outcomes. Okay, so an outcome of an experiment is an observation of the experiment. So what are the results from the experiment? And the following are example of random experiment and its outcome. Okay, so we have this experiment, a coin is thrown. So we have this coin. So let me see if I have a coin. It should have, I should have some coins in my wallet. Okay, so this is my coin, 50 cents. Okay, this is my coin. So I have the flower part and then the bottom part. So we have two outcomes out of a coin when we throw this coin. So it's either the upper part or the lower part. So we call it head and tail. Okay. Okay, the next one is a die is rolled. So a die, what is die? Die is singular for dice. So dice is more than one. Die, dadu. So we have a singular, a die, and then dice is more than one. So a die, one die is rolled. So the outcome will be 1, 2, 3, 4, 5, 6. So you know what is die, right? So dadu, if you play the game like Jutaria or anything lah. So we have this die, and then we have outcome 1 or 2 or 3 or 4 or 5 or 6 because we have 6 surfaces of the die. And then next one is a record of the grade of an experiment. So you have examination. You have your results for the AM015, right? So most of you get A or A minus or B plus, B, C plus, C minus, D and F. Okay, and then toss 2 coins. Okay, so if we have 2 coins, let's say I have here 2 coins. So there may be not only head and tail outcome. So if I throw the first coin, I get head, and then the second coin, I can get head, or I can get tail. Okay, so the first coin also can get tail, and the second coin can get head or tail. So that's why we have four possible outcomes. It's either head, head, both head, or both tail, or one head, one tail, or one tail, one head. Okay, so these are the outcomes when we toss two coins. Okay, a sample space of a random experiment is a list of all possible outcomes of the experiment. So if you look at on the right table, the right column, sorry. So these are all the possible outcome if we do the left experiment, the left column experiment. Okay, so we can say that all of these are the sample space, a list of all possible outcome of the experiment. So the sample space is usually denoted by S, capital S. Okay, so the sample space of an experiment can be illustrated by set notation, or Venn diagram, or contingency table, two-way table, or another one is tree diagram. So this set notation we can put in a form of bracket lah. The couple set notation. Uh, so this we will see the example later. And then Venn diagram, you learn it in set in high school. Venn diagram, we have two events and then or three events. So we have the probability or the element in the Venn diagram. And then contingency table. So we have, let's say, two events, the coincide between the two events, and then the tree diagram. So this usually comes with the conditional probability. So later we will, in the next lecture, we will focus on the tree diagram. Okay, so an event is a collection of one or more outcomes from a sample space. In other words, an event is a subset of the sample space. Let's say it's like when you have the population and you have sample, right? So this is a subset of the sample space. So event is a subset of sample space. Okay, so we have a certain event in this sample space. So let's say we have the results of mathematics AM015, right? So that is the sample space. So event may be the student get excellent results, which is A and B. The result is A and B. Maybe the student with the poor result, so maybe the result is C and D. Okay, so we can say like that, like for an event. Okay, so let's see some example. If a die is rolled once, the event is getting odd number is. So we have 1, 2, 3, 4, 5, 6. So odd number from 1 to 1, 2, 3, 4, 5, 6 is 1, 3, and 5. So 1, 3, and 5 is the subset of sample space S, which is 1, 2, 3, 4, and 5, and 6. Okay, so this is a subset. This is an event. Okay, odd number is an event from the sample space when a die is rolled. Okay, simple event is an event that includes one and only one of the outcomes for an experiment. So let's say getting one. So compound event is an event that has collection of more than one outcome for an experiment. Okay, so what are the outcomes and sample space for the following experiment? So we have this example, example 1, tossing a coin once. So we know the sample space will be head and tail. Okay, so that will be the sample space lah. So we have to list out in a set notation for the sample space. So experiment for tossing a coin once, we have head or tail. So the sample space should be in the curve bracket form. So the S is equal to a curve bracket of head or tail. Okay, so continue with B, tossing a coin twice. So as earlier we have seen that it will be have head, tail, head, head, tail, head, and tail, tail. Okay, so the sample space will be in the form of bracket. S is equal to a curve bracket of HH, HT, TH, and TT. And the last one, rolling a die 1. So we have 1, 2, 3, 4, 5, 6. So we have to write down the sample space equal to S equal to 1, 2, 3, 4, 5, and 6. So we separate the outcomes by the comma notation. Okay. Now, example 2. List a sample space showing all possible outcome when a pair or dice is tossed. So we are throwing the dice 2 times. Okay, so the first one we have 1, 2, 3, 4, 5, 6, and the second die also have 1, 2, 3, 4, 5, and 6 outcome. So there will be how many combination of the pairing? Okay, so 6 by 6, it should be 36 observation. Okay, so how do we find all the possible outcomes? So we can do this table to get the couple, the pair of the outcomes. So let's say this is die 1 outcome, this is die 2 outcome. Okay, the row 1 is the die 1 outcome, the column 1 is the die 2 outcome. So we have 1, 1, 1, 1, 1 for die 1 with 1, 2, 3, 4, 5, 6 for die 2. Okay, if we have 2 on die 1, we may have 1, 2, 3, 4, 5, and 6 for die 2. So that's why every number 1, we have 6 outcome. Every number 1 of die 1, we have 6 outcome. Lah. Okay, so that's why we have overall of total of 36 possible outcome. Okay. So all of these are the possible outcomes. So we can write down all of these as the sample space. Okay. So all of this will be the sample space. Right? If you want to write down the sample space, the sample space is equal to, so you put a curve bracket from the first one to the last one, the 36. Okay, the 36 outcome. So all of these are the possible outcomes for the when you throwing the 2 dice. Okay, probability. Probability. The probability of an event A occur is defined as the number of ways in which A can happen, expressed as a fraction of the number of ways in which all equally likely event, including A. So it's like a bit complicated, right? The probability. So the probability of an event A occurring is denoted by probability of A, PA, P of A, where P of A is equal to number of successful outcome and divide by the total number of all possible outcome. So successful outcome from an event A lah. Okay. So divide with the all possible outcome. What is all possible outcome? All possible outcome is the sample space lah. Okay. Number of members of A. This one is another way to write down the probability of A. So number of members of A. So how many numbers of member of A, and then numbers of member of possibility space. Okay, so NA divided by NS. The number of event A divided by number of sample space. Okay, basic laws of probability. So we have this is the basic information, characteristic of the probability lah. As A is a subset of S, or possibility space. Okay, so A is a subset of S. There can be 0, it can be also 1. Okay, so if it's 1, and if P probability of A A prime or A bar is the complementary event for A, then the probability of A prime or A bar is equal to 1 minus probability of A. So you have to know when to use this complementary event. Okay. We know the possible outcome when throwing a coin is head or tail. So the number of possible outcome is 2, right? But to get a head, we only for the sample space. But to get the probability of heads, so that's why the probability is equal to 1 over 2. Cool. So if it's a late, probability of late, so to not late, what is the probability? So what is the concept that we need to relate? Okay. So it's equal to, it's given as 1 over 4. So probability is not late. So then it's not late. So it's a complementary of late. So L prime. So we can use the complementary event formula. So probability of L prime is equal to 1 minus probability of L, which is 1 minus 1 over 4 equal to 3 over 4. Okay. So now union of events. Union, not union party, union of events. The union of events A and B consists of all elements which are A or B or both. It is denoted by A or B, A union B. So this U symbol here is talking about union. You can represent as A or B or A union B. Okay, so this is the Venn diagram. Sorry, this is a Venn diagram of a sample space. So this rectangular here is the sample event. So in the sample space, we have two event A and B, right? So this event A and B might be coincides, okay? There is intersection between A and B. But for the union of A, B, we need to consider everything include A and B or both. Okay, so this is the area that I have shaded by the blue pen is the union of A and B. So how to find this union of event? Okay, so intersection event is another event that will occur when both A and B occur. So it's only happen when it's coincide with each other, the intersection. Okay, so it is denoted by A and B or A intersect B. So this inverted U is the a intersect intersect symbol. Okay, so in this sample space in Venn diagram, the intersection will be this area. Okay, the one where A and B coincides. Okay, sorry. So the probability, sorry, let's see. Okay, the probability of union of two events A and B is equal to, so this formula is the standard formula. You cannot just tukar-tukar dia. No, you have to use this formula for the general event. So probability of A union B, this is always true in every event. But there is special case for this event. So probability of A union B is the addition between probability of A and B, and then we subtract with one probability of A intersect B. Okay, let me show you one example. So if I have this event A, this is event B. So there is intersection between these two event A and B, right? So if it's just take probability of A and B, so the intersection part will be have two times. So we have double of the intersection part. So that's why we need to subtract one of the intersection part. So we edit out the intersection, one of the part of the intersection. So that's why we will have to subtract with the probability of A intersect with B. Okay? What is this? Sorry, yeah? Okay. Where A union B is the event where A occurs or B occurs or both events occur. A intersect B is the event when both A and B occur together. Okay, so let's see some example. Probabilities of events C and D are such that probability of C equal to 4 over 9. Okay, probability of C is equal to 4 over 9. Probability of D is equal to 1 over 3. And then probability of C intersect with D is equal to 1 over 9. So to find the union, okay, to find the union, we have to use the general formula lah, which is probability of the union equal to probability of the C plus D minus intersect. Okay, so you have to write down like this. So what is probability of C? 4 over 9. D, 1 over 3, intersect 1 over 9. So 4 over 9 plus 1 over 3 minus 1 over 9 is equal to 7 minus 1 is 6 over 9, which is equal to 2 over 3. So this is the answer. So just substitute all the value given. So, okay. The question might ask you, what is the probability of intersection? Then you have just to rearrange lah. If we have the union and the individually probability. Okay, probability of mutually exclusive event. So two events A and B are called mutually exclusive if they cannot occur at the same time. What it means by cannot occur at the same time. So, where is the event where the A and B occur at the same time? Okay. So, for example, if a number is chosen random for the set 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, A is a selection of even number, B is a selection of odd number, C is a selection of prime number. Okay, so even and odd number. Even and A and B for the even and odd number are mutually exclusive. Why? As none of the numbers in this set are both even and odd. So we don't have any number that are both even and also an odd number. No. So this is the event where it's a mutually exclusive event. Okay. So but B and C are not mutually exclusive because both some numbers are both prime and odd. For example, 3, 5, 7, 11. 3 is a odd number and odd number, but it is also a prime number, right? Okay, so B and C cannot be mutually exclusive. So the probability of either A or C can be found as follows. So this is A, probability of A is equal to 5 over 10 because we have 4, 6, 8, 10, and 12. And then probability of C is equal to 3, 5, 7, 11. Okay, for prime number, right? So probability of C is equal to 4 out of 10 because sample space is equal to 10. So the union, so this is probability of either A or C. So A union C. So probability of A union C is equal to 5 plus 4 over 10. Okay, why? Because A union C, A is even, right? C is prime. So even and prime cannot happen together. That's why we don't have probability of A intersect with C. Okay, we don't have it. It's equal to 0. So actually it's the same as the original formula, but we subtract by 0 probability because the intersection is not there. Okay, so we just add up the probability of A and C. So 5 over 10 plus 4 over 10 is equal to 9 over 10. Since neither event A nor event C can occur simultaneously, thus the probability of A and C occurring at the same time is 0. This can be denoted as probability of A intersect with C is equal to 0. So there is no intersection. So means that for two mutually exclusive events, the probability of the intersection will be equal to 0. So if A and B are mutually exclusive event, then probability of A intersect with B is equal to 0. Okay, so we can say that if probability of A intersect with 0, the intersection between two events cannot be happen, then it's a mutually exclusive event. Okay, they cannot coincide. Okay, so this is a mutually exclusive event. You can see the picture here representing the mutually exclusive event. So we have the sample space, and these two events A and B are not coincide with each other. There is no intersection. So that's why this is a mutually exclusive event. So probability of union is equal to A plus B. Okay, example 6. Let's see example 6. Okay, a statistical experiment has 8 equally likely outcomes that are denoted by 1, 2, 3, 4, 5, 6, 7, and 8. Let A is an event of 5 and 7, B is 1 to 5, C is 1, 4, 6, 8. So event A and B mutually exclusive. So because we know already it's mutually exclusive is the intersection is equal to 0. There is no intersection element. So do we have any intersection between A and B? Yes, we have the same element 5 in both of A and B. So A and B not mutually exclusive. But for B, even B and C mutually exclusive? No, we have 1. 1, 1 on both B and C. So it's not mutually exclusive. How about A and C? Do we have 5 in C? No. We have 7 in C? No. Okay, so we don't have anything that the same in the both A and C events. So this is mutually exclusive event. Okay, so we can directly know from the all the outcomes from each of the events lah. Okay, so how about question D? Question D, we need to calculate lah union A and C. Because A and C mutually exclusive, then the union you just have to add up the probability from A and C. Okay, for B. Okay, so we can write down A intersect with B, we have an element 5, then A intersect with B is equal to 1 over 8, so not equal to 0, so not mutually exclusive. For B and C also the same, now we have the same element 1, so the intersection is 1 over 8, not equal to 0, therefore B and C are not mutually exclusive. But for C, A and C, we don't have an element, so we can put element with nothing in between or empty set. This is the representation of empty set. Then the probability of A intersect with C is equal to 0. So therefore, A and C are mutually exclusive. And then D, probability of A union with C. A union with C, here we can find by using addition between probability of A and probability of C, because the intersection is equal to 0. So it's just subtract with 0 lah. So we can skip the subtract the 0. Okay, so what is probability of A? We have 2 elements out of 6 sample space, so 6 or 8 sample space, so 2 over 8. And 4 elements for C out of 8 elements in the sample space, so 2 over 8 plus 4 over 8 equal to 6 over 8, which is equal to 3 over 4. Okay, so for D, another question is probability of B union with C. So we have to add up the probability of B and C and then subtract the intersection. So what is probability of B? We have 3 elements out of 8, 3 over 8. And C, we have 4 over 8. And then the intersection between B and C is 1. So 1 out of 8 elements. So 1 over 8. So 3 over 8 plus 4 over 8 minus 1 over 8 is equal to 3 over 4, which is 6 over 8. Nah? The same as 6 over 8, which is equal to 3 over 4. So you have to simplify for the number. Okay. That's all for this lecture. Okay, so I hope you guys can look at the tutorial question for chapter 7, topic 7. Okay, so we will continue on the next lecture next week on Sunday. Yeah? Okay, see you guys next week. So thank you.